So, no prizes for guessing. We've got a Danita 3000. I think it's the multi version. We'll find out in a moment, won't we? So it says on my sheet there's a receive problem. It could be a... Oh, and there goes the telephone. Oh, well, that was a great start to the video. What was that, 30 seconds? So I think this is probably going to be a return, because he says it is reporting as dodgy receive. It is a multi. We'll run with the power lead supplied. That looks like the same as the... Oh, get the duster. It looks like the same as the TCB 1100 from TTI. I don't know whether it's the same polarity. It's something I'll verify, because we have those. I'll get it connected. I think these are early 2000s, like 2004 or something like that. I'm going to need to... Actually, I'm going to have to open it up first, because if there's a fault, if it's anything like... Do you remember we did that skip tech set, and there was a missing capacitor because it had blown up, but somebody had removed the debris to stop it rattling? Then I had to open one of ours up to find out what the missing capacitor was. So, you know, rather than that person leaving the duff capacitor with the set, so it was easy to identify, or replacing it themselves. Oh no, they sold it on with the evidence removed. There was a comment on the video when I did the Radio Wheel 201. If you remember, I opened the seals on that with my fingernail. It's a comment that didn't get through. It ended up in the sandbox. And I'm not going to let it through, because I can see where they're coming from. If you use the hairdryer, said the person, you could have probably got those off intact. Why? I've unsealed it, haven't I, to service it, because it was no longer going to work. So if I put them back, it would be disingenuous, wouldn't it? I don't get that one. I see where they're coming from, but no, definitely not. Right, microphone. 2, 4, another 6-pin one. So I'll leave the wrapper on that until such time as I have to do the deviation, and if we get it working, on the air test. And I have had these before, badly set up from the factory. I didn't expect to have to put the soldering iron on. So whilst the soldering iron warms up, we can have a quick look at potential dodgy capacitors, and there aren't any. So all that is lovely. Also printed off, if it's the right version. Of course it's not the right version. That's not the right version. That's the 2797 version. The earlier one. but the layout might be sufficient to not have to worry. Just make a start on this. Plug the mic in. Switch on at 12 volts. This is current limited. Disconnect the speaker. Right, and we're going to connect up the speaker mounted on the wall, just in case there's a malfunction. I don't want to damage the test equipment, of course. The test equipment has been on for hours. And we'll switch on. When I get the lid to... You know what, I'm going to put a screw in that lid, because it's sliding all over the place. And obviously if it slid into the works, it wouldn't be ideal. Right, switch on. UK, right. So channel 20, we're going to transmit. I'll put picture in picture on. And it is 2.5 watts. Oh, I'll just check on the others. It's on the other scale. It's 2.8 watts. That's better. 2.8 watts. Because it's an 80 channel set, we'll do this as CPT channel 1. We should do that as UK1 and UK40, so I'll re-evaluate that. Just so we're in the centre of the band. Wrong button. Right, channel 40, 2.7 watts. Channel 1, 2.8 watts, which is what we've got for 20. And if it's programmed to do the band, it is. We'll go to channel 1 of CPT, and we've got 2.9 watts. It doesn't have low power. It isn't a 2781 set. It's multi, obviously, because it says so. A little quick look at deviation. We'll go back to UK channels, because the deviation meter is set up for that. Wallow. It isn't, you know. We've been doing CPT. Wallow. That's a bit low. It says 1.5. Anyway, we'll get the other test set on the job, which I'll switch on ready. I've got 1.5. We're not doing VCO. Frequency. Frequency is 79113. So it's just very, very slightly low. Doesn't matter, but we'll do it anyway if it's adjustable. 79113. When we key up, what does the meter show? It shows 4. This is probably one of the last sets with a relative power meter, because these days they're all fake, aren't they? They just key up right across the thing, whatever the power's actually doing. I've shown that before. You know, take the output transistors out, it still says it's transmitting. Transmit current 1.115. meter lamp. It kind of has one because it's got a backlit display. Doesn't have PA. So we'll just now go into the signal generator and put 2779 whatever in. Was it 113? 79113. And we've got the signal generator at 1 microvolt, and that is 10.1. So it's not that. It's awful. No wonder he's reporting. Right, we'll go over to the test equipment and we'll see how many microvolts it is. And we'll turn the scrolls down. Let's put the cyanide meter on and you can see. It is 1.5 microvolts for 12 dB, but it sounds awful. .25. I doubt it's going to do 20. It will do 20 for 47 microvolts. That's like S5. Squelch. Let's put the squelch to full. Just reset the attenuator. Show the controls and drop that. Put the squelch to full. And actually it comes in at an OK 200 microvolts. And let's see what the sensitivity is like. Bearing in mind the set's deaf. And let's turn the squelch to set to threshold. Signal generator back on. Straight in at 0.3. So considering it sounds awful, the S meter 100 microvolts, and it's showing, well, for S9 it's 300 microvolts. So that would say a lazy needle. Going to quickly run through the transmitter. And the phone is ringing. Right, so having got up, got back, I don't know, we'll get on with this. I'm just hoping there isn't a fault. You know, it's surface mount, not easy to do anything. Right, transmitter. So on the previous version, and it's going to be the same apart from the synthesizer, just a different board layout, we should have got RV201, which is there, as AM modulation, if we have access to AM. I can't remember on these. We should have 101 as the S meter, which is there. We should have 105 as TX meter, which we don't appear to have got on this. That figures, doesn't it? We've got 103 as squelch. It's nothing like the same, is it? January 2007 it's dated. It's a little bit later than I thought. So we've got actually more presets than the... That's going to be deviation. It depends whether it has an automatic power control or not. I'm going to have to stop the video once again and go and look on my computer to see whether we've got a circuit diagram for the CPT, that's what I'm on about, for the multi version. Well, the good news is that last time I looked, probably a year ago, there wasn't a circuit, and this time there is, from Danita's own website. So I've got the circuit diagram, and it clearly says multi. We've got the layout, and I can see, that makes a change. Let's have a go through these with you. So we've got transmit, as I expected. We've got 301, 302, 303. On receive we've got L101, 102 and 103, wherever they are. (103), yeah, 1, 2, 3, RX, RX, RX. I should have got the coloured pens out. That is the detector. It does have a TX meter. It's 202. TX, RX of the meter. RV2 is squelch. It's taking me about 30 minutes to do this. I think that's power, not clear. 101 is, well, that's deviation. And 101 should be, no, 201 should be AM mod. Come on, where's that then? That one. Right. So the first thing we need to do is put it into that and turn the. You're tuning the transmitter always with the power at full, but you do it quickly because you don't want to burn out the transmitter. Yeah, I'm right. It is, and at full whack, it's 3 watts. Now then, we need to do this on channel 1, so we're in the centre of the band. The customer hasn't said he wants it optimising for UK only, so we do it to the centre of the band, assuming he wants it across the 80 channels. That was correct. That was correct. That brings us up to 3 watts. And we've got some airspace coils. Placement of this is already factory optimal. Just check that one. We've just come into the timeout timer there. I didn't know there was one. Right, so it's warmed up, it's doing 3 watts. I'll have to drop this slightly because you can't... You know what I've done, folks? No wonder it's only doing this power. It's still going to be right, but I've got the power supply at 12 volts, haven't I? That's what comes up, jumping up and down, answering phones. So it's still going to be optimal. I'll just have to turn the power down if it goes beyond 4. It's 3.5. Just absolutely check that one. Yeah. I could say 3.6. I'm going to turn that now to, because you don't have it at full whack, it's the point at which it makes no more difference. Still 3.6 watts, but I've turned it down a bit. It's like having a car in the wrong gear. You put your pedal to the metal, and it's, of course, cars have gears in Britain, don't they? You put your pedal to the metal, and it's not going to go any faster because you're in the wrong gear. You're just drawing more current. So we've got a current consumption now of 1.275 amps. I'll let it cool down before we do those others. May as well do the deviation. So I'll unplug from this test set and we'll go to the test set behind me. I'll just take the bag off the mic for a second. Get up, down and all that malarkey on the mic. Right, so we had, according to the Marconi test, it was only about 1.5 deviation. Wow, oh, it's about 1.8. Deviation is 401, which is there. Let's hope we can get a little bit more out of it. Wallow. Wallow. 2.3. I mean, it won't be quiet at that, and it might be really well processed. So it was 1.8, it's now 2.1 to 2.3 kilohertz. So we may as well do the frequency. I'm doing all this and we may not get the receiver right. Should have done the receiver first, shouldn't I? I'll set it on channel 20 because I'm used to doing that. It's going to be the same whatever. 2779115. Just change that slightly. Okay, it's like that, is it? You know what? It's so finicky, I'm going to leave it at 122. Of course, I've lost the pen, it's under the remote. 2779122. We do the meter now. I just put the bag back on the mic. We'll only expose that again when we come to the on the air test. We've got a sharp contrast tomorrow because it's one of those DNT base stations. Might be in several parts because they're usually very problematic. I keep vowing though we're not doing any more of those. Right. So here we go. Meter. So when we key up, we know it's doing 3 watts, 3.5, 3.6. I need to make sure, I want it to read 4 on the front because that's how you set them, but I want to make sure it's only just 4. Otherwise, it won't know if the SWR changes. So just check, it's that one, isn't it? Yes. It's nice to see a TX meter on a relatively modern set. So at the moment we've got it right down there, so bring it very carefully up. So it's just reading 4. Whoops. Like that. Then if I drop the power, let's just see whether we can do that. Just drop it down to 12 volts like I was doing it on. And when I key up, it probably doesn't read 4 anymore. No, it doesn't. So it shows you the difference. And that's what we want it to do. Back to 13.8 volts. So that's that done. So, you know, I could say, no, it reads 4, but no, it needs to be right. So here we go. This is going to be the bit that's a problem. Something's microphonic as well, but that's probably the way it is. So I'm going to start, we'll go over to the oscilloscope and we'll start with looking at the detector. Might just be that that's miles out. So I'll put 100 microvolts on the signal generator, we'll turn the volume up so I get a decent trace, which for some reason isn't in the centre, and I've not altered it. Right, and the detector is 104. We've got a broken filter, have we? Go to the cyanide meter. It's that one. Miles out. Stupidly miles out. That's alright. And that's alright. I'm going to just look at this with the S meter to make sure I've got it in the right place. I can always put it back right with the cyanide meter if this is wrong. That looks right. That's right. Yes, it's right. I'm going to recheck the detector. And see whether we've got an improved receive. Let's go over to the cyanide meter again. I'm going to want to hear this because, you know, you could have crystal filters that have gone lopsided. Well, we've got 0.58. 0.49. .20 is now 1.8. Make sure squelch still works. So I've got squelch to full. Let's go over to the attenuator. Shift that so you can see the one we're working on. I want it to be 100 microvolts. It isn't. It's still working at 200, but just on the edge of being where we want it. Oh, that was that slightest touch. Now it's the wrong way. I'm never going to get that back right, am I? Yes, I am. Right, that's done. That's now 100 microvolts, which is where I want it. And then we'll turn that down. Put the squelch to stamp to threshold. Signal generator back on. Straight in at 0.3. Set the meter. .100 microvolts, and it's showing S9, which is what we want. It's exactly where we want it to be. So that's come right without intervention. If we needed to have done it, it's 101, which is there. So that's now 100 microvolts. So that's as far as that goes. Let's see. There isn't a separate AM detector, is there? Unless it's going to be that, isn't it? That's going to be the AM detector. So we're going to have to reset the signal generator. La-di-da-di-da. We're going to have to... I'll put the frequency counter up. We'll have to set it now to CPT. $27,205. I'll tell you what, we'll do it on channel 40. Don't have to wind my fingers around as much. Right, so that's CPT channel 40. So let's put it to CPT. And there we go. And now we need to go to AM. Do we have to reprogram it? I think we do. And I'm going to have to look at the instruction book, can't I? Because I'm never going to guess in a month of Sundays how it's done. Is it... It's going to be switch on, probably with the AM FM button. Is it that one? Yes, it's that one. So put it on CE instead. No, it's not C. Turn it off, turn it back on again. Set it to try EU. Yeah, it's in AM now. That's FM. That's AM. But it's set for low power because it's before the time. It's before now 2014. You see, so Germany had got only 1 watt or something on, something like that. Let's go to AM. There we are. And then back to the oscilloscope. Turn the volume up. And check the AM detector, which I am... Yeah, oh, that was out. Whoa. Ah, that was worth doing. There is a different fee when we do these AM FM sets. It goes without saying because we're backwards and forwards a lot more time. So that's covered that. While we're in AM, we'll do mod. We can do that on this test set. There's no problem with doing that. So we'll go to meter 1. I better unplug this extension speaker. It's going to give me feedback. I'll do it through the thing. It's going to be... We're going to get a near enough reading. We're going to have to retune it. Wallow, wallow. It's about 95%. So that's all in order. Yeah, it's 1 watt in that. So what you have to do is put it into a different country, which was allowed 4 watts at the time, and I think we normally have it in France or Spain. So I can do it because it is permitted because it's a CE approved set. France, let's try that one. So now if we're in AM, it's still 1 watt. Okay, let's try Spain. Hey, 4 watts. And it's actually doing, it's doing 3.6 just the same. So that's proof of that. So I must remember when we do the on the air test, when we go over to AM, I'll have to reset it for Spain. Right. Well, we can. I'll tell you what we'll do. While we're in that, we'll go to FM in Spain. CPT therefore now channel 1. We'll just do the transmit power, which was 3.6 watts on channel 1 UK. It's 3.8 watts on CPT, which is what you're going to expect. So when we go back to channel 40 UK, it's probably 3.5. So you know what? When we do the on the air test on channel 31 UK, it's going to be towards the worst performance of this set, and that's good. It shows it at its worst. So we need to set it back to UK. As I say, these were made before 2014, so this is why it's a faff. Mind you, some sets still are a faff. Have I gone past UK? I must have done. So we want channel 40 UK. Let's look at the power. So 4 watts is there, and it's 3.4. So that's as balanced as it's going to get. And you can see before it was 2.7, 2.8, 2.9. It's now 3.4, 3.6, 3.8. I'm going to have a quick talk to Mr. Chippie over the system, because have we done everything? We've done AM mod. We've done receive detector. Yeah, we've done everything. So I'll put it on the aerial while it's still in bits. Depends where he is, of course. He may be anywhere within the acre site. See if there's any good buddies on 19. Oh, it helps if we plug the speaker back in, doesn't it? Well, no, Roger. It's got a half-second delay when you're going to transmit. I'll have to remember that as well. We'll go to 31. Tango 21, Mr. Chippie, in a position to be able to talk back to me on the Midland base. Roger, I'll get you the walkie-talkie. Tango 21, Mr. Chippie.
Tango 21, go ahead.
Yeah, testing 1, 2, 3. Okay, that sounds alright.
Yep, roger that.
Right. I'll put this together and we'll restart the video. Right, so we'll just have a flick round. Especially if we put it in the right band. A Roger. And EU. Back to UK. He's over deviating because he's distorting. So there you are, the Danita 3000Multi, which should actually be working now. Thanks for watching.